Good day, everyone. My name is Rebecca Lilly for the International Association for Energy Economics. It gives me great pleasure to welcome you to today's webinar entitled Mechanisms for Rebound Effects of Solar Electricity Prosuming in Germany. We are grateful to our moderator, Reinhard Madlener, and our distinguished panelists for today's timely discussion. First, a little bit about the International Association for Energy Economics. We are the largest association specializing in the field of energy economics and provide a forum for the exchange of ideas, experience, and issues amongst professionals interested in the field. The organization produces 2 professional journals, a newsletter, and holds conferences and virtual presentations along with a host of other products and services that you can find at our website at www.iaee.org. If you're not already a member of the association, we welcome you to join. A few housekeeping matters in regard to today's webinar before I hand things over to our moderator. First, this webinar is being recorded for those that cannot participate in today's live event. If you have questions for the panelists, please click the Q&A button at the bottom of the Zoom window and type your question. We've allocated time at the end of the webinar to read and answer them. And now I would like to introduce you to our moderator, Dr. Reinhard Madlener, full professor of energy economics and management at the School of Business and Economics at RWTH Aachen University. Reinhard, over to you.
Thank you, Rebecca. This is a great pleasure to have organized this webinar today, and I appreciate your interest in the topic of prosumers, but also rebound effects. I will start sharing some slides where I will introduce you to the topic, but also have a brief overview of who we are and where we are. I'll start sharing. Takes maybe a second, yeah. And I hope you can see the full screen now from my computer. So that's a group picture from our center. It's an interdisciplinary integrated energy research center at Aachen University in Germany. And it has been established in 2006. And our group, FCN, Institute for Future Energy Consumer Needs and Behavior, has a size of about 25. We did some rebound research before. You see here a selection of articles, and if you're interested, I'm happy to share them with you. Feel free to contact me about this anytime. And as you can see, one paper I did with Hendrik Schmitz here, direct and indirect rebound effect, that was even published in the Energy Journal lately. What is rebound? I take it some of you are rebound experts. Some of you want to know more about rebound and prosumer households. The most simple formula is R equals 1 minus A over E. So the ratio between the actual and expected energy savings, and rebound gives us an idea or a percentage what energy is not saved if an energy efficiency improvement has happened. The story goes back to 1865 when William Stanley Jevons wrote about the coal question, because he was getting worried during the Industrial Revolution in Britain that due to energy efficiency gains, coal would not, or efficiency gain would not alleviate coal shortages, but quite the opposite. And a discussion has been going on since the 1980s with Brooks and Kasum and others, also in the journal Energy, in the Energy Journal and in the Energy Policy Journal at that time. And since then, rebound has come in waves back. And we have now much more empirical evidence, but also good theoretical papers that have been contributed over the last couple of years. Now, most rebound studies have been on the direct rebound. That's important to notice, but there is also an indirect one. You can also measure rebound at the meso or sectoral level, and finally at the macroeconomic or economy-wide level. Our study here, and mainly most studies, focus on the direct rebound effect only. Now, next graph is from Steve Sorel, also a well-known figure about rebound research, and this is nice and picturesque. Tells you if there is a fuel efficiency gain of a car, then you can either drive more miles with a more fuel-efficient car for the same fuel bill, or you could decide to spend the money saved elsewhere or for some other energy service, like taking an airplane or an extra holiday somewhere in Spain, as it says here. But you can also think about the embodied or gray energy. If we have a technical change, then the capital stock changes, and that also has its energy implications. And we can then try also to measure the implications, say, on the evolving infrastructure or the structural change in the industries and so forth. So that's the rebound topic. Graphically, we have energy consumption that is affected by an energy efficiency gain. That would lead to an expected new energy consumption, as you can see in the middle graph, the middle column. I have the laser pointer on now, and then we can measure direct rebound, indirect rebound, and in the extreme, the rebound is larger than the gain of the efficiency. And that's what we call backfire. And in the end, you would end up with higher energy consumption despite of an energy efficiency gain. And the research question is out there, how likely is that? Can that happen? Does it happen? But it's not the topic of our talk today. The second topic we address is prosumer rebounds. And again, we have done several studies. You see some references from our own work at our institute. And without much further ado, I will then lead over to Tuba, who will then share the slides herself. So I'll stop sharing here, and we will share with you and present the study that you can see listed here. Tuba, the floor is yours.
You're muted.
Okay, great. So I guess you can hear me now, right? And you see the slides. Okay, perfect. So, okay, thank you very much. So, yeah, I will just give you first a quick institutional background on actually our study. So in Germany, traditionally, there is a feed-in tariff system, which traditionally has guaranteed private and other PV solar panel investors or adopters a rate, a retail wholesale market price rate that is a feed-in tariff rate that is about the retail or wholesale market prices for the subsequent 20 years upon the adoption decision. And this rate depended traditionally on the system size and the installation year. However, since around 2011, actually for the retail customers, they have observed grid parity, which means that the feed-in tariff rates now are lower than that of the retail electricity prices. And so there is one background that the incentives and the regulatory framework of subsidy schemes have changed substantially in Germany. And our study is actually going to try to identify that variation and then feed that integrated into the analysis of the rebound effects. Now, obviously, this policy scheme has helped increased investment in renewable energy technologies. And among those installations of PV systems by private households have contributed to that development immensely. But at the same time, even though there's that penetration in the market, there is recent evidence that shows, documents the solar rebound effect, which is referred to as that private household upon installing the solar panel, actually having increased their consumption, electricity consumption. And if such an effect exists, then this is potentially going to undermine the environmental or grid benefits of PV adoption. And at the same time, for policymakers, this is going to be important to clearly identify that effect, because either for the projections that we might come up with for future projections, but at the same time, for example, determining the optimal subsidy level, we would want to know if such an effect exists. And so the central question that we are addressing here is, or a broad question is, how is the energy consumption of private households are affected switching to renewable energy technologies from traditional ones? And then specifically, we are going to look at possibly, are there any unintended consequences or effects of changes to the subsidy scheme that actually are going to have some consequences for the energy consumption behavior of private households. And very specifically, we're going to look at the prosumers, so the solar PV panel adapters that are just private households. And the research questions that we're going to address are twofold. The first question is, are there differences in electricity consumption between prosumers and consumers? And to that first set of questions, actually, there is already substantial evidence in the literature. But then the second set, if such an effect exists, then we're going to ask the question, what are the mechanisms that explain that difference? And very strongly, we're going to focus on, as I already hinted, on the prices and incentives the changes in that domain rather than the other two potential mechanisms. But we are also here running a survey questionnaire that actually tackles the other two in an indirect way. So the other potential mechanism might lie with the attitude differences between consumers and prosumers, for example, on environmental preferences. But at the same time, prosumer households might actually systematically differ in terms of their technical equipment or household appliance stock. It might induce, or it might immediately imply that a prosumer household, for example, upon installing a solar PV panel, already have a smart meter and hence have more frequent consumption feedback. So we're also going to look into some of these, or integrate some of these into our analysis. And now, if you look at the recent literature, there are a few studies. I don't want to go into details of these studies, but there are, so for the first set of question, whether or not there are differences in prosumer and in energy consumption between prosumers and consumers, Q and others, and Bepler and others, both recent studies provide evidence from the US reporting a persistent rebound effect after actually they use a similar methodological approach as we do, which is propensity score matching. Even after they match the sample, they see that there is a persistent effect of, in the case of Q study, 18%, and in the Bepler and others, 28.5%. Now, Bepler and others have actually a higher estimation. This might lie with the fact that their study do not actually acquire very detailed information on the household level consumption, so potentially leading to not an overestimation, as they are not really looking for controlling the co-adoption decisions, or they don't have data on that. For example, other technologies such as e-vehicles, etc. And then we have two opposite studies showing actually opposite evidence. Frontal and others and Oberst and others, they are showing that there is no strong, or they're showing evidence that there are no strong rebound effects for the case of Germany. And Frontal and others, in their working paper, they're actually strongly focusing on a time period before grid parity. And that might become clear later on that we're going to look at that variation in our study. And that might be the reason why they're not observing such a strong effect. And Oberst and others, they employ a similar approach with matching, but they also do not find a significant effect after actually they match the sample. And so we provide, what we do in our study, we provide additional evidence on this first question, but our contribution lies more with the second set of questions, that is the mechanism. And to the best of our knowledge, we're not aware of any systematic research yet there. And so let me quickly introduce you or walk you through the theoretical foundation of how we're actually going to approach identifying the rebound effect. So standard microeconomic theory is assuming that consumers respond to marginal prices. But currently, or the recent evidence, at least from the electricity market, suggests that electricity customers are actually sensitive to average electricity prices. And so for the electricity customers, what matters is the total, the amount of the bill that they are observing. So here it becomes important that lagged averages are actually, for electricity customers, are a much stronger predictor of consumption, their consumption, rather than looking at marginal price changes. And following that line of evidence, and if a private household is going to install a solar panel, then the produced electricity from the solar panel is going to be at the zero marginal cost, and so that is going to reduce the average price that particular prosumer actually can enjoy per kilowatt hour consumed. And so if this is true, if we follow the evidence from Ito and others that electricity customers are responding to average prices, and upon installing a solar PV panel, then the average electricity price is expected to fall for that private household. That is going to, that might then potentially induce actually those customers to consume more electricity. And if that is the case, then in our study, we are going to interpret this as the solar rebound effect. And so looking back at the case of Germany, what happened is that with that subsidy scheme, the feed-in tariff rates have been actually falling over the last decade or so, because the technology of solar panels is becoming cheaper. But at the same time, we observe the opposite trend. The retail electricity prices, price rates are actually rising in Germany. And that is also due to the German government's goals of committing to the energy transition and passing part of the those costs to the retail customers in the form of levies and taxes. So now what this resulted, these opposite trends have resulted in the grid parity around 2011 for the retail customers. And again, in Germany, though, the prosumers are able to choose between full feed-in and self-consumption at their own discretion. And so what happens with this picture is that before 2011, all the private households that have installed systems actually have, for them, it is more profitable to feed in the generated amount of electricity to the grid. But the opposite trend exists for those private households that have actually installed systems after 2011, because for them, it is much more profitable to self-consume that amount. And so here it's just a descriptive evidence or the picture that we can provide from our own data set. And so this shows a repeated cross-section of all the households that we observe in our data set. And that is those households have installed systems from 2000 to 2019. And we have conducted our survey in 2020. So the prices, the average electricity price rate here on the picture comes actually from the prices in 2019 for each household. So that's why it's a uniform distribution. But if we are going to look at the market prices, this picture is even going to be much stronger, because around 2000, the prices are much lower. And in 2020, we will observe a much higher electricity price. But still, it replicates the picture that we want to show, which is before 2011, actually feed-in tariff rates are much higher than the electricity prices that the households observe. So that makes basically feeding in a more profitable option for those households that have installed systems prior to 2011. And for those households that have installed systems after 2011, they have much higher incentive to self-consume. Now, if we are going to account for that self-consumption after 2011, we're going to see that they're going to enjoy a lower electricity price, or that is going to effectively reduce the average electricity price those households observe. And so that then immediately means that they actually might have an incentive to consume more, those households that install systems after 2011. And so I just want to provide you a snapshot of some of the summary findings from our study. So what we find is, on average, we observe, just like Q and other study, a very close number to theirs, 19% of solar rebound effects among German households. And this effect persists after actually we match our sample. And we then in our study, what we do differently is we explicitly consider the regulatory changes in the subsidy scheme in the analysis, and we try to identify whether this variation actually in the subsidy scheme explains part of the rebound effects that we observe in our sample by splitting our sample to those prosumers that install systems before 2011 and after 2011. And indeed, if we do that exercise, what we see is that we observe no significant differences in those households, prosumer households to consumer households before 2011, who have installed systems before 2011. And we observe that there's a significant difference in their electricity consumption if we are to look at the households that have installed systems after 2011. And that's around 700 kilowatt hours per annum compared to households that we match our sample to. Now, also, what our study does maybe differently from the others, or we believe that we are close to getting to a real effect or estimating something that is less biased, simply because we have a survey questionnaire that actually have already had a very large set of detailed questions on household appliance stock or ownership of highly energy consuming durables. So with that, we are actually able to look at co-adoption decisions. We are explicitly looking at controlling for for example, the ownership of e-vehicles or other highly energy consuming devices, which some of the previous studies have been done, potentially leading them to overestimate the effect. So our methodological approach here is the propensity score matching. But before I talk about this, clearly empirically we have one setback or a problem here, because if we think about the adoption of PV systems, this is not a random decision. So PV system adopters are going to systematically differ from the regular customers, regular consumers who do not have a PV panel. That is also simply because they might have bigger, they might be living in bigger houses or more environmentally conscious, etc. So that leads to a sample selection bias that we actually want to eliminate before we tackle the research question at hand. And so in an ideal setup that we can imagine actually is going to consist of a randomized control trial. In that setup, we would want to install PV systems on randomly selected set of households, which would be our treatment group. And then we would have a randomly selected set of control group. So these will be regular consumers. And then ideally, we would want to observe them over a longer period of time to even differentiate the short and long run effects, and then compare actually energy consumption behavior of prosumers before and after matching to that of the control group. But now this is very difficult due to obvious administrative and legal constraints. And so what we are doing is we are using propensity score matching, which is introducing in the data a quasi-experimental variation, and in a sense recreating a setup like an RCT. So now propensity score matching estimates, what it does is it estimates a randomized experiment. And what we do to approach the research question at hand is we collect data on prosumers and consumers separately. And prosumers are going to be our treatment group and consumers are our control group. And here I have an example of some from another study, but I think it is intuitive in terms of understanding what the propensity score matching does. So we have two dimensions in the data, and here each point of C represents the control observation and T's represent the treatment observation. So what it does is propensity score matching takes those covariate dimensions or the different dimensions of the data into a single scale, which is what we can see here on the right-hand side. So this value that is taken anything between 0 and 1, it can be called a propensity score, which is the probability of being treated. So in our case, this is the probability of being a prosumer or having installed a solar panel. And this can be estimated using a logit or probit regression. And so if we do that, then what it does is it takes a multidimensional data into a single dimension. And once actually we project the data onto a single scale, then we take each treatment units and then match them to the closest control units that are on the scale. And so this approach then obviously throws away after, compared to the previous picture, throws away those observations that are far away from each other on the scale. And so we're ending up with a smaller sample size. So just the intuition is that if, for example, randomization works perfectly, then we would have for each unit a propensity score of like tossing a coin. Then we would observe a propensity score of 0.5 for each of these units. And now in an ideal case, if propensity score works well, then we would actually observe after we throw away that unmatched sample, all the C's and T's laying on top of each other. And with that, I think I would like to now stop sharing and give the word to Hendrik, who's going to talk more about the data and the results.
Excellent, thank you, Tuba. By the way, the audience can ask questions in the Q&A. You can do that throughout the presentation, and we will save some time at the end for a discussion.
Okay, then I'll continue from here. Thanks a lot. And hello, everyone. Good morning, good afternoon, or whichever applies to you. So I'll continue from here. First, I would like to talk some more about the data that we collected to do this matching analysis. So we designed an online survey that we then conducted right before COVID, as you can see, which I guess is lucky also in the sense that there should be no effects in terms of consumption, for example, based on the COVID pandemic, because this was done early 2020. So we only focused on homeowners because, of course, tenants can also be prosumers, but there the rules and regulations are very different. So we only focused on homeowners here. We have obviously both prosumers and consumers in the sample. And as you can imagine, there are a lot more consumers in the world and also in Germany compared to prosumers. So we tried to still get a meaningful number of prosumers, but that is usually also the case in matching, that the treatment group is a lot smaller than the control group. I mean, not always, but in this case, it's definitely true. And so in this survey, we focused on three sort of main areas. The first one was the question of information. So how well do people actually know about their own consumption? Do they have smart meters, for example? Do they check regularly how much they actually consume? Secondly, and that's also sort of the central focus of this study, of course, is the incentives and the tariff structures. So we asked people to actually look at the last electricity bill that they had, and yeah, to tell us how much they consumed in terms of electricity, how much they paid for it, what the prices were. And then for the prosumers, of course, very importantly, we also asked them when they actually installed the system, how large it is, because that determines the feed-in tariff, and then also how much they feed in, if they do feed in, how much they self-consumed, and yeah, other questions related to that, because of course that is the consumption especially is of course the outcome that where we're looking for the treatment effects. And then finally, we also included some questions on environmental attitudes, preferences, behaviors, and of course sort of the standard sociodemographics such as age and income, education, and so forth. So to give you some descriptive statistics, so this is just a selection of the variables that we included in the survey and then also in the matching. So not everything that we asked in the survey is also included in the matching, and this is also just a small selection of that. But just to give you an idea of the distribution of these characteristics, and then also to show you how the matching actually changes the mean values for some of those attributes. We can see, for example, that first of all, we see that there are significant differences in some of these variables between the treatment, the prosumer group, and the consumer group. For example, prosumers are on average a couple of years younger than consumers. They also live in larger homes. We can see that here in the living space variable. And significantly also, they own a lot more electric vehicles and also more heat pumps. And so this already shows us that there are systematic differences between those groups, as we would also expect. So we cannot just compare the differences in the consumption and then claim that that difference is because people are prosumers. And also on the right, we can see that after the matching, so after we eliminate some of the consumer group, some of that sample, the mean values for those attributes are now different, and for the most part, they are now closer to the treatment group, which is exactly what we hope for if the matching works as we intend it to work. So for example, for age, now we can see that after matching, the mean age for the consumers is now closer to the value of the prosumers, for example, and the same for some of the other variables as well, or for most of them actually. Of course, there are always exceptions, like as you can see at the bottom here, the Green Party support. Now it's actually after matching, the consumers are actually further away from the prosumers in the mean. But for most of the variables, the difference becomes smaller after matching, which means that now the consumer and the prosumer group are more comparable because they are closer in these variables to each other, which is again what we would hope for if the matching works as intended, because that's exactly what the point of the matching is. It tries to balance the covariates between those two groups. And just to show you one more sort of condition that needs to be fulfilled, that is called common support. So we can see, as Tua mentioned, the propensity score is this univariate score between 0 and 1. That is the probability of being treated. This score is assigned to each of the observations based on their characteristics. And the common support now states that, or this condition now states that there needs to be some overlap in that probability distribution between the two groups in order to have unbiased matches, or even to get any matches that are meaningful at all. So what that means, for example, if all those red bars, that's the propensity score for the treatment group, if they were all on the right here, so if they all had really high propensity scores and the control group all had very low scores, then there would be no overlap potentially, or very little overlap. And then in a sense, the logit model that predicts the treatment would work too well, actually, because if we had something like a perfect predictor, then we could no longer actually find meaningful matches. So the goal of this logit model that creates this propensity score is not to perfectly predict the treatment, as maybe in some other logit models you would try to do that, but to actually balance those groups. So we do need some area where for a certain propensity score we have both treated and control observations, as we have especially here in the middle. So it seems like this is fulfilled for us, and I can move on to the results. So first of all, this is just for the entire sample without splitting between the years or anything like that, but just all the prosumers, all the consumers in one group. Then we match, and then we compare the consumption levels. And if we just compare the means without any sort of matching or regression or anything else, just comparing the means with the t-test, we find that the prosumers actually consume significantly more. So that's around 411 kilowatt hours. That prosumers consume more per year compared to consumers. But this, as I said, would be a very sort of naive way to think about this, because of all those significant differences between those groups that I previously mentioned. So this is just sort of for comparison, as a comparison of those means. Now, what we see here in the second line is that after the matching, first of all, the value or the difference in consumption, in yearly electricity consumption, is now smaller, and also it's no longer statistically significant. So what that means is that after the matching, we now no longer have a significant difference between those groups in the electricity consumption, which we had before when we just looked at the two groups and just compared the consumption levels. So this would then indicate that there is no rebound effect. We know there is a difference between prosumers and consumers, but it can be explained not by the presuming, but it can be explained by some of the other characteristics, because if we match on these characteristics, the difference diminishes and it's no longer significant. So just based on these results, we would conclude that it's not the presuming that creates those differences in the consumption, but it's some of those other factors that may also be related to presuming. For example, the possession of electric cars. And since we control for that in the matching, then of course the difference diminishes. Now, if we do split up the sample, as Tuba mentioned, roughly in 2011, feed-in tariffs were for the first time lower than the electricity price. So now, if you installed your system after 2011, then self-consumption would be much more profitable compared to feeding in, and before this was reversed. So we should really compare not just all prosumers, but specifically those prosumers with those very different incentives. And also, since the feed-in tariff is guaranteed for 20 years, so if you installed your system in 2005, for example, you still will receive that high feed-in tariff until 2025, until those 20 years are over. So you still have those incentives today. And now if we just look at the Prosumer group who installed until and including 2011, we also find that the treatment effect is not is first of all quite small. It's even negative, but it's also not statistically significant. But if we just look at the group of prosumers who installed after 2011, now we have a quite significant, so an effect that is both statistically significant and also quite large at around 682 kilowatt hours per year. So yeah, and on the right, you see just for reference the results for the whole sample. So now this is a different picture in the sense that if we just focus on those prosumers who have a very strong incentive to self-consume, here we find that they consume significantly more even after controlling for those different characteristics through the matching. So this of course implies that it's not just those different characteristics such as the living space or the age or the possession of electric vehicles and heat pumps, but there's something else going on. And yeah, of course the suggestion would then be that it's those different incentives. And just to show you as a sort of robustness check, we also ran a regression adjustment model, which fits separate regressions for each treatment level. We find a very similar picture for the entire group and also for the prosumers who installed in 2011 or before. There's no significant effect. After 2011, prosumers who installed after 2011 have a significant effect. It's slightly smaller than in the matching, but still statistically significant. So what does that mean in terms of rebound? As probably most of you know, rebound is usually expressed in percentages. And now since in this case, in the prosumer case, we don't have an efficiency increase as in sort of traditional rebound estimates. So as far as we know, it's not entirely established yet how to calculate rebound in this particular case, as you know, most of the research is also quite new in the case of prosumer rebound. So there are at least two ways to calculate rebound, and the first one is to calculate it as the ratio of the additional consumption because of prosuming divided by the additionally generated electricity. And if we put in the numbers from our survey, then we arrive at around 21.6%. So just to give you an example, that would mean that a prosumer who generates 5,000 kilowatt hours per year, which is a fairly average number, then that means that almost 80%, so around 4,000 kilowatt hours, are actually used to substitute grid electricity. So this is then used in self-consumption or by feeding in. That doesn't really matter because either way it substitutes grid electricity. But the remaining 21.6%, which is around 1.1 thousand kilowatt hours, would then be excess consumption, which should be, of course, taken into account if we think about things like projection of future energy demand, for example. Just like in regular rebound, when people say we will make this car 10% more efficient, that does not mean there's 10% savings. It's 10% minus the rebound. And that is a similar logic here. And secondly, as an alternative, you can also, of course, calculate rebound as an additional consumption compared to the consumer level, to the baseline consumption. In this case, we arrive at this close to 19% that we also mentioned before. And yeah, to conclude, so as you saw in the main model, so with the full sample, we find that there is no statistically significant additional consumption after the matching. But if we split the sample, then we find that for those who installed after 2011, who are also mostly the prosumers who self-consume or who have a strong incentive to self-consume, and we can also see in the data that they are mostly the ones who do use self-consumption. Here we find a significant effect of additional consumption. And yeah, as we suggested previously in the theory section, this may be because people mostly look at sort of average electricity prices instead of the marginal prices, because of course, because of the opportunity cost of not feeding in your electricity, the marginal incentives don't really change, but the average prices, of course, are lower if you have self-generation at a marginal cost of 0. So we would not claim that there's a strong causality here in this type of framework, but it appears as though the regulation and the feed-in tariff that is below the electricity price would then induce these rebound effects that we find. Of course, this does not mean necessarily that feed-in tariff should be higher just to avoid those rebound effects. That's of course a different conversation that you can also see here in the next steps. First of all, of course, it might be interesting to figure out if there are also other factors that can explain those rebound effects, except for just these price structures, which we haven't looked into in detail yet in this work. And then also secondly, what are actually the sort of the policy implications also in terms of welfare? Should we try to avoid these rebound effects in some way? Or should we just accept them? They might also be welfare enhancing for those people. To some degree, that might also be sector coupling, because if people buy an electric vehicle because they are prosumers, first of all, we don't know if there's causality there, but if that happens, then of course, that would substitute regular gasoline or diesel consumption, for example, which in this work, we did not consider gasoline, for example. So if people substitute gasoline with electricity, then it would show up here as a rebound, but it might not necessarily be a bad thing from a policy point of view. So there are still some open questions. And with this, I would close and thank you for your attention. And then also, I think we can go into the Q&A.
Yeah, that's right. Thanks, Hendrik, as well. As the audience can see, we are currently revising the paper, but are happy to share it with you. Just send us a request and we'll send it back to you. So I see the first message in the chat. Does the model consider the network congestion?
I guess I can just answer. No, we don't consider this at all. Basically, we abstract from all sorts of network effects that might also be interesting to consider, but we don't implement that at this point.
Will also be an interesting aspect for the welfare analysis that we plan, right? Okay, anybody else who has a question or a comment, please feel free to use the Q&A. We have about, plus minus 20 minutes left over that we can use. We also have some backup slides if we don't see enough messages in the Q&A. Not for the moment. Hendrik or Tuba, are you ready to maybe go through some of the backup slides?
So I think the backup that we had now was actually quite outdated. So at least for my part of the presentation, I deleted those because they're no longer relevant. I don't know if you have anything else, Tuba.
There is now.
But I see one more.
There is one more in the chat. More details on the propensity score.
So yeah, I think it would be nice if who addressed the question can specify it a little more in which direction.
Yeah.
More details is needed. How it works, or in our very application.
Is it possible to be more specific? What detail you would like to have deepened? Did we have any more in the backup on the propensity score matching? Not really, right? How the dimension transformation is implemented.
Yeah, sure. I mean, I can just briefly start, and then of course you can join. So the first step of this transformation is you run a standard logit or probit model where the treatment status, so in this case presuming or non-presuming, which is just 1 or 0, is the outcome variable. So that's what you explain. And you explain this with the characteristics that you have, where you would include all the characteristics that you suspect have an influence on the consumption and then also on the treatment status. So just to give you an example, as we saw in one of the slides, the presumers on average, they are about 3.5 years younger than the consumer group. So then what that means is that you would include the age variable also in the logit to estimate the propensity score, because it appears to have some sort of influence on whether or not someone is a presumer or not. It might, of course, not be causal in some way, but since there's a difference there, we can at least suspect that age has an influence on being a presumer. And the same, for example, with income, of course, because we can imagine if you have more money to spend, you might much more easily be able to actually invest in a solar PV system. So this should also be included. So you would include all the variables that you have that where you think they have an influence on the treatment status. And then you get a logit model. And then so for the logit model, then for each of the variables, you have a coefficient, of course, in how they are significant or not, and how they influence the treatment status. And then basically you do sort of a point projection or point estimate for the propensity score for each of the individual observations. So in other words, if the logit model shows us that someone who has an electric vehicle is much more likely to be a presumer, which is the case, that is what we found in the data, then when assigning the propensity scores, anybody who has an electric vehicle would also get a higher propensity score, because having an electric vehicle has sort of a positive influence on being a presumer. Now, of course, some people are also consumers who also have an electric vehicle, but then these are the people that would have a higher propensity score, even though they are not presumers, right? So the distribution of the variables then determines your propensity score, which, since it's a probability, it's between 0 and 1. So in theory, there might be people that have all the characteristics of a presumer, like having a heat pump, having an electric vehicle, being younger, being well-educated, having higher income, having a larger home, but still they might be consumers. I mean, those people, of course, can also exist. And then you would have some people that have a very high propensity score, but they're actually consumers. And then those people are quite likely to also then be matched, because probably they have a counterpart in the treatment group who also have a higher propensity score. Yeah, but so I hope that that clears it up a bit. So you run a logit model that shows you which variables are influential in the treatment status. Now, we cannot claim that this is causal. There might be reverse effects here also, but you do that, and then you assign the propensity score to every observation to reduce the dimensionality of all those characteristics. And then you drop some of the observations, and you drop always those that have no clear or no close counterpart in the other group based on the propensity score. And then you have a reduced sample, and that sample is then closer together in the characteristics on average. So I hope that clears up the process a bit, or otherwise, of course, feel free to.
Thank you, Henrik. I think it did. And now we got another question, very interesting. Did you check the sensitivity of your results with respect to the propensity score methods, i.e. number of nearest neighbors, caliper kernel? Is it a problem that your samples do not match on all variables, notably EV ownership and Green Party voters? Hendrik, you can see the question. Maybe we break it down into two, right? The first one is about the method, the sensitivity of the results with regard to the methods used.
Yeah, so we did include a number of different methods, also including caliper, and also with replacement, without replacement, for example. And substantially, the results did not change. Yeah, we don't have slides for that, but that's yeah, we did control for, or we did check different methods. Yeah, for the second part, I mean, yeah, it may be an issue, or I mean, we would wish that it would work for all the variables. I guess especially for electric vehicles. The issue here is that just there are not that many people who own electric vehicles still, and this was 2 years ago, so the number was even lower. So I think that's sort of one of the limitations here, that yeah, it's hard to match exactly on that for those characteristics where the distribution is so uneven, where a large majority of people don't have an electric vehicle. So yeah, that's, I think, one of the limitations there. And for Green Party, I don't quite remember if that was even necessarily significant for the treatment status. So probably is a bit less problematic. But for EV ownership, of course, that has direct implications on the consumption as well, right? Because I mean, we know just from owning an EV, most likely you will have a higher consumption. So that could definitely be a limitation there.
Okay, thank you, Hendrik. Now I don't see any new questions. The audience can still write some questions into the Q&A. And maybe it's also interesting to mention to the audience that the last amendment of the Renewable Energy Act in Germany was done last year. And so there will be major changes in the level of the feed-in tariff. And the electricity price in Germany has been one of the highest in the world, and especially in Europe. And that will also change because the levy system will be reallocated or reorganized. And so that will be the next challenge for German studies of this kind, to accommodate for those major changes since the last EEG amendment. All right, then I think we answered all the questions there were. We have a few minutes left, so that's the last chance you have. And if no other questions pop up, then I think we want to thank you for your interest as an audience. Thanks also for those very interesting and useful questions to be discussed. And with that, I will conclude this webinar and hand back over to Rebecca. Thank you, everybody, including Hendrik and Tuba.
We'd like to thank all of our distinguished panelists for an outstanding webinar. This webinar will be available on IAEE's website for future download. If you're not a member of IAEE, we encourage you to join by visiting www.iaee.org. We thank you for attending, and I officially close this webinar.